Okay, this video is about polynomials. Okay, so the first thing you need to know is about the leading coefficient test. So you look for the coefficient of the highest degree exponent in the equation, okay? The degree and the sign of that coefficient determine the shape of the graph. All right, so here's the little table that you'll eventually memorize. If it's even, think of it, if it's even, think of your good old parabola, okay? Has two arms. If it's a positive parabola, then we know it opens up. If it's a negative parabola, we know it opens down. Okay, that should be a little familiar to you. So what we're saying is if the leading coefficient is positive and even, the highest power is even, it's basically going to look kind of like a parabola. It may have some bumps along the way, but the two outer edges are going up. If it's even and negative, it's going to go down. Two outer edges going down. There could be bumps along the way, but they're still going down. So this is your basic shape for even or odd. I mean even. If it's odd, think of your linear equation, positive linear equation. Okay, ends go opposite directions. Left falls left, rises right. If it's negative, then it's negative slope. Rises left, falls right. So now we use infinity notation to get there. So what I'm going to do is on this table, I'm just going to show you what I mean, is what we would say is if both arms are going up, we would say as x approaches negative infinity, all right, think about your graph. As x approaches negative infinity, what is the y doing? F of x approaches positive infinity. As x approaches positive infinity, that means what's happening here on the right side of my graph, f of x, the y values are going to positive infinity. With both arms down, I would say as x approaches negative infinity, f of x, what's happening here on the left-hand side of my graph? Those are going down, so the y values are going to negative infinity. As x approaches positive infinity, f of x, again the y values, what's happening on the right side, that y-axis, they are going to negative infinity as well. Right? Now, for odds, same kind of notation. As x approaches negative infinity, what's happening on the left side? The f of x goes to negative infinity. As x approaches positive infinity, f of x approaches positive infinity. Okay, but think about your linear function. Okay, this is this one. Okay, and then this last one, as x approaches negative infinity, f of x approaches what? We use the arrow to say approaches, by the way. Approaches, so think about what's going on the left side here. The y values are going up, so y approaches positive infinity. As x approaches positive infinity, my x coordinates are going positive. What are my y coordinates doing? They are going negative. So f of x goes to negative infinity. All right, so let's just try some of this. All right, here's my little table that you'll learn. So let's look at this. Example 1, just using infinity notation, that's what I just showed you. As x approaches infinity, f of x approaches whatever. Okay, that's what I mean by infinity notation. Describe the in behavior of f of x. Okay, so look at this one. What's the leading coefficient first? This is the leading term in the whole thing. It has the highest exponent. So I look, it's negative, and that power is odd. So it's this one. Okay, so think of my linear, a negative linear equation. It's going that way. So I write as x approaches negative infinity. What's going on here? As x approaches negative infinity, f of x approaches positive infinity. As x approaches positive infinity, f of x approaches negative infinity. This is my infinity statement. Okay. What I want you to do as you work these is to sketch it out. I want you to sketch it out and then write it out. So there's two parts to your answers, the sketch and then infinity notation. If you can get the sketch and have issues writing it out, I can give you partial credit. So let's look at number 2. What's the highest exponent? Well, this one. What's the coefficient of that? That's a 1 and it's positive. So it's going to match my even degree positive, so it's going to be like a happy face, happy parabola. All right, so in the infinity notation, I say as x approaches negative infinity, f of x approaches, think about it this way, if I'm on this side, what's my y values doing? They're going up, positive infinity. As x approaches positive infinity, f of x goes where? Well, so as my x values come over here, what's my y value doing? It's still going to positive infinity, right? So what you're going to use is the same notation on every problem. Same rules apply. Now, using all the clues that we know in behavior, we know zeros, we know multiplicity. We have enough information to sketch the graph. Now, you just take baby steps one by one and apply them to what we have, okay? So first, let's look at our zeros. We know zeros are x-intercepts. So at 4, we know it's going to touch the x-axis here, and we know it's going to touch the x-axis at -3. Then multiplicity tells us how is it going to touch. Okay, this one means it's going through. This one means it's going to bounce. Okay, so write that out. It has a degree of 3, which makes sense because 2 plus 1 is 3. Okay, and a leading coefficient of 1. So this is where that table comes in. It has an it's an odd power and it's positive, which means the graph is doing this. Okay, as x approaches negative infinity, y is going to negative infinity. As x approaches positive infinity, y is going to positive infinity. So you know the outer edges are doing this number right here. Okay. Now you have to figure out what's going on in between them. Now, at x is -3, we know it goes through the graph. And it's having to come from down here based on our in behavior. So I draw the line from under here. I know it has to go through. Okay. And I know it has to keep coming. It has to go this direction eventually. But it has to touch the x-axis over here where x is 4. But how does it touch it? We said it bounces. So I know the line is going to continue to extend and come and bounce off of this and then bounce back up. And there it's going the same direction. All right? So you use the clues to help you draw the curve. All right? Let's try one more. I have a 0 at 0. I have a 0 at 2 and a 0 at -3. Okay? What is the 1? Multiplicity of 1 means it goes through it. If at 3 it flattens it, and multiplicity of 1 goes through it. So I don't have any bouncers on this. Okay? It has a degree of 5 and a leading coefficient of negative. So it's a negative odd function, which means it's going to do this. My two ends are going to do this. So on the left, I know it has to start from up here, and on the right, it's going to end going down. Okay, that's your general curve. I know it's going to go through each of these 3 points, but it's going to flatten where x is 2. All right, so I know it has to go through these points. This -3 has to go through it. It has to go through at 0, and then it's going to flatten. So you need to show flattening. Somehow show that flattening line coming back down. Okay. These just take practice, so don't get overwhelmed. Just take one step at a time and figure out the way the curve is going to go. All right, I'm not looking for perfection. I'm just looking for the major landmarks, and that you show me how is going through that x-axis. All right, on your own, I want you to try this one. But all you need to do for this right here is just give me the infinity notation. We'll work on sketching the graphs when you get to class. Okay, good luck. We'll see you in class.